Okay, so today's main topic uh, is TCP, Transport Layer Overview, TCP. So that's my main focus. So let's see. I highly recommend that you use especially when you look at the TCP Transport Layer lecture slide. Please use the slideshow. Okay. So you know that it's a TCP, right? So please use this slideshow when you actually review this slide for yourself. Okay. Now, the TCP is the definition. Why we need a TCP layer. So if you look at the OSI model, this is layer 4 transport layer, right? It's equivalent to the TCP layer in the TCPI model. So basically the TCP layer is a layer 4, whereas IP is a layer 3, right? Definition of the transport layer is responsible for creating and maintaining a logical connection between the end and the endpoints. So I want you to focus on the term endpoints. And there are two protocols at the transport layer. First of them is a TCP, and another one is called UDP. Okay, so we have two main protocols. And initially, my main focus is going to be on TCP. Okay. Now, so we have application data, right? And your operating system kernel is going to, when they need to send this data, they first attach this TCP header to the data, right? And then after that, they attach IP header to this segment. This is called segment, and once IP header is attached, IP header and the data, this is called packet. And then your NIC card, your operating system or your computer, right, is going to attach a frame header. This is called frame. The reason that, okay, so IP header is going to be used by mainly layer 3 device, which is router, right? The router is called layer 3 device because its main task is to read an IP header and process, right, based on the IP addresses in the IP header, the source and destination IP address. Okay, the frame header is read by a switch, and that's why the switch is called layer 2 device. You know, the frame header, this is typically this is used for the Ethernet protocol. We're going to learn Ethernet protocol later. Right, the local area network LAN. LAN is layer 2, pretty much. Okay, now I want to let's take a look at the TCP header. Okay, the TCP header is, when you look at the TCP header, I know there is many fields, and then the first people look at this TCP header and they feel intimidated because there are so many things to probably memorize. But for this class and for with a lot of reason, you don't have to really know every field in the TCP header. But there are a couple of important fields that you have to memorize in the TCP header. Source port number. So now let's take a look at this. I don't know if I can increase. Okay, good. So what? I want you to take a look at this source port number, which is 16-bit, and destination port number is a 16-bit, sequence number and ACK number. And as you can see, there are 6 flags, but I want you to only memorize 3 flags. Each one is like 1 bit long. The first one is ACK flag. By the way, this is a flag, ACK 1 bit. This ACK flag is different from this acknowledgement number. acknowledge number is a huge number, so 32-bit long. ACK is either can be 1 or 0. When ACK is on, that means 1. When ACK is off, that means 0. And then another thing, SYN. This is a SYN flag, and SYN is for the synchronization, SYN, and you have a fin flag. So now, only thing that for now, like probably you need to memorize 7 fields: source port number, destination port number, sequence number, and ACK number, and then ACK flag, SYN flag, and fin. Fin means finish. Fin flag. So total of 1, 2, 3, 4, 5, 6, 7. Okay, 7 fields in the TCP header. Okay. So let me end my lecture here.